Hey, this is Coach Latham, your SOL review coach, and today we're going to talk about an important topic in geometry. We're going to cover two parallel lines cut by a transversal in under 15 minutes. First, three things that you should know from review, three concepts. The first one is the concept of a complementary angle. Complementary angles are angles that add up to 90 degrees. The picture usually looks like this, where we've got a right angle, and then inside of that, we've got two angles. And if we called this angle A and we called this angle B, we would say that angles A and B are complementary because together they add up to 90 degrees. They add up to this right angle. If we knew that the measure of angle A was 30 degrees, then we would just do 108 or 90 minus 30, and we would know that angle B is 60 degrees. 30 degrees and 60 degrees prove that it's complementary because 30 plus 60 is 90, and they make the right angle. Supplementary angles kind of work the same way. The pictures usually look like this, where you've got a straight line, and on one side of that straight line, it's divided into two little angles or two other angles, and those angles are going to add up to 180 because there's 180 degrees in a straight line. If this were angle A and this were angle B, we would say that angle A and B are supplementary. If we knew that angle A was 50 degrees, then we could find out how big angle B is by taking 180 minus 50, and we would know that angle B is 130 degrees because 50 degrees plus 30 degrees adds up to 180 degrees, which is a straight line. Some people get these confused. An easy way to remember the difference between complementary and supplementary is that it's always right to complement somebody. So those two go together, right and complement. Then supplementary angles add up to 180. The third item that you need to remember from earlier in geometry is that vertical angles are angles that are created when two lines cross each other. So that's an ugly picture right there, but we've got two lines that are going to cross each other in this picture. We've got this one right here and this one right here, and there are four angles that are created. Two of the angles are right here, and these two angles appear to be the same size, and they are. So we know that if this angle is 30 degrees, then this angle over here also has to be 30 degrees. The other angles are going to be 150 because the 30 going with 150 makes a straight line. But the angles that are directly opposite from each other are congruent, or the same measure. The new material that we're going to talk about today has to do with two parallel lines are cut by a transversal. Now, a transversal is almost always identified as the letter T, and then you can either be told that the lines are parallel, you can be asked to prove that lines are parallel. The symbol to show that the two lines are parallel, if you ever see the little double arrows on lines like those, and that shows that line A and line B are parallel. This sets up 8 different angles in the picture. We've got 1, 2, 3, 4, 5, 6, 7, 8. There are 8 angles created when a transversal cuts two parallel lines. There are special relationships between these angles, and the first one we're going to talk about are corresponding angles. Corresponding angles are angles that are basically in the same position. In this case, we've got line M and M being cut by the parallel T, and the little angles up on the top right at each intersection, this blue one up here and this blue one down here, appear to be the same measure, and in fact they are. So those two angles are said to be corresponding. They're top right and top right. Another set of corresponding angles would be the green ones here. They're bottom right and bottom right of the two intersections. Then we've got top left and top left of the two intersections. And we've got bottom left and bottom left of the two intersections. All 4 sets of these angles are going to be equal to each other. Whatever this angle is right here, let's say it's 100 degrees, then we know this one's 100 degrees. If we know that this angle down here is 80 degrees, then we know that this one's got to be 80 degrees. If we know that this one over here were 110, then we would know, well, it couldn't be 110. it looks like it's smaller than a right angle. So let's go ahead and make it more appropriate. If we knew that this one was 75 degrees, then we would know that this one is 75 degrees. And if we knew that this one was 105 degrees, then we would know that this one was 105 degrees. The corresponding angles are congruent. Another set of congruent angles are called alternate interior angles. This one right here is going to be congruent to this one right here. I don't really care if people memorize this because you can always figure out that these two have to be equal by the stuff that we've already talked about. This angle right here is corresponding with this angle right here, and that kind of proves that these other two are congruent because this angle and this angle are vertical angles. So actually we know all three of those are the same. Alternate exterior angles are congruent. Again, it looks like it makes sense. This angle right here is going to have the same measure as this angle right here, and that's true. And then there are two sets of angles that are supplementary. In other words, they're not congruent. They add up to 180 degrees. These two right here, they definitely don't look like they're the same size. This one looks like it's under 90 degrees, and this one looks like it's over 90 degrees. They're not the same, but together they add up to 180. If you were to go walking down this line like that and then make a hard left and then make another left, you would be leaving in the exact opposite direction that you came in on, and that's kind of another way of thinking of 180 degrees. So these two add up to 180, and the same thing is true for these two angles. They're not the same size. You can tell just by looking at the picture that this one is bigger than this one. They do add up to 180. So what I want you to do is to hit pause right now and then try and identify all the corresponding angles, alternate interior angles, same side interior angles, alternate exterior angles, same side exterior angles, and then next to each one either put congruent or supplementary, just to make sure that you've learned what we're supposed to know so far. Hit pause and I'll be back with the answer. Okay, we're back with the answers, and you could hit pause again if you wanted to take some time to check yourself. I really like color coding these things. I've identified blue angles and green angles, and all the blue angles are equal to each other in the picture, and all the green angles are equal to each other in the picture. We talk about corresponding angles first, and I've got angle 1 and angle 5, angle 2 and angle 6, angle 4 and angle 7, angle 3 and angle 8. You can see that they end up being corresponding angles, and they're all congruent. I've got alternate interior angles. Those are congruent, 4 and 6, and then 3 and 5. I've got same side interior angles. They're supplementary. They add up to 180, and that's 4, 5, 3, 6. So those are blues and greens. They're different colors. They add up to 180. Alternate exterior angles are congruent. That's 1 and 8 and 2 and 7. And then same side exterior angles, they're supplementary. They're blue and green angles. They add up to 180. All right, once you accept that corresponding angles are congruent, you can figure out every other angle in a picture. If you have two parallel lines cut by a transversal, once you know just one of them. So let's work this one through. Let's say that I know that this angle is 80 degrees and that I've got two parallel lines cut by a transversal. Well, then I automatically know that this angle right here is equal to 80 degrees because they are corresponding angles. The green angles correspond, so they're both equal to 80 degrees. Well, if I know that both the green angles here are equal to 80 degrees, and this one is equal to 80 degrees, then I also know that this angle is equal to 80 degrees because that's a vertical angle. So that means that this angle is equal to 80 degrees, and if I wanted to color code this one to match, so now all four of my green angles are equal to 80 degrees. So looking at the bottom picture here, I know all the greens are 80, so I could write an 80 here, I could write an 80 here, I could write an 80 here, and then all that's missing is the other four angles. Well, they're all going to be the same, but what are they going to be? It's going to be the supplementary angle of 80. And since you add 100 to 80 to get 180, then these other 4 angles are all going to be 100 degrees. So that's how you work out all the angles when 2 parallel lines are cut by a transversal. Here I have another problem for you. I want you to hit pause and try and work this out. You're given that the measure of angle 1 is 45 degrees. Find the measure of angle y. Okay, we're back. Angle 1 is said to be 45 degrees, so I'll just go ahead and change that to 45 degrees. If angle 1 is 45 degrees and these 2 lines are parallel, then that means that this angle has to be equal to 45 degrees also, because they're corresponding angles, and this angle plus this angle make a straight line, so they add up to 180. 180 minus 45 degrees is 135 degrees, so that's our final answer. Y is 135 degrees. Moving on, we've got another SOL type review problem. Go ahead and hit pause and give this one a shot. Okay, we're back. The important part of this question is finding the relationship between these 2 angles. They're either equal to each other or they add up to 180. Again, I like to use my color code to make this clear. This blue angle right here is equal to this blue angle right here because they're corresponding angles. And of course, this angle right here is also equal to them because these 2 are vertical angles. So these 2 angles are equal. So the equation that you're going to use is 3x minus 35 is equal to 7x minus 115. And I have the solution to the equation here for you. Take your time and hit pause if you need to, but when we solve for x here, we get an answer of 20. So the solution, or the correct answer, is B. I have another SOL-like review question for you to try. Go ahead and hit pause and work on this one. Okay, and we're back, and like I said, this is an SOL released item. It was on a previous SOL test. This is one where you would want to use the marking instrument on the top of your screen on the SOL test. You can highlight some of these lines. The important part here is that lines A and B are parallel, so on your SOL screen, or what I'm going to do on my smartboard, is I'm going to go ahead and just mark those lines. These are the 2 that are parallel. And if I'm trying to figure out what x is, then this is the transversal that I'm interested in. All this stuff down here below is unimportant to the problem. They try to confuse you with extra information. So now I'm just looking up here at the top part. If this angle is 120 degrees, then I know that this angle is 120 degrees because they're corresponding. So in order to find out what angle x is, I do 180 minus 120, and I get 60 degrees. So this angle is 60 degrees. They make a straight line, and the answer is D. All right, here's the last SOL practice problem. Go ahead and take a look at this and then hit pause. All right, there's a lot of different ways to get to the answer on this problem because you can really pick any set of corresponding angles and work it out. I like top right. I've got that this one's 101 degrees. I've got that this one is 89 degrees. This one is 99 degrees because that's vertical to that 99. And this one right here is going to be the supplement of 91. 180 minus 91 is going to be 89. So this angle is 89. So to figure out which 2 lines are parallel, I'm looking for the 2 that have corresponding angles that are equal. 89 is my winner. They match. So B and D are parallel. I hope this has been helpful for you. Again, this is 2 parallel lines cut by a transversal in under 15 minutes. Now go study for that test.